Factor by grouping is going to be the last type of factoring we're going to look at. And factor by grouping is specifically used when you guys have 4 terms. So in all of these examples that we're going to look at, they all have 1, 2, 3, 4 terms. 1, 2, 3, 4 terms. So grouping is used when your polynomial or your expression has 4 terms to try and factor. So, and you really just, it's almost like reverse foiling. So in your 2 examples here in A and B, you factor out a common term from the first group and then the second group of terms. It'll always be in order for you guys. So what will happen is 3x cubed plus 3x squared, factor out 3x squared, 5x plus 5, you can factor out a 5. So those terms that you pull out go to one set of parentheses, and then the set that should match once you're done factoring goes in the other set. So if you look, like I see that there's 2x plus 1s when you factored, but you only use one of them in your final factoring, because what would happen if you guys foiled, you do 3x squared times both, that's like this part, and then the 5 times both, that's this part. So even though there's technically 2x plus 1 in the factoring piece in step 1, you only use one in your final answer. So let's sort of do some examples and see how it goes. So for x cubed minus 3x squared minus 16x plus 48. So you're always looking at the first 2 and then the second 2. So looking at x squared minus 3x squared, we're looking to either factor out a number or a variable from both of those. So you can't factor out a number other than 1, so we won't worry about that. But from x cubed and x squared, you can factor out x squared. The lowest number that one of them has, because you can't pull out 3 because they both don't have 3 to offer. So x squared, and when you pull out that common term, you're just dividing. So when we divide, we subtract exponents. So x cubed divided by or take away x squared leaves you with 1x, minus 3x squared take away x squared leaves you with 3. Okay, now if you guys look at your second group of negative 16x plus 48, when that second group starts with a negative or a minus sign, you should be thinking or trying to pull out a common factor that's negative. So that's what this is saying over here, because we really want that expression in the second set of parentheses to be positive. So when your second grouping of numbers starts with a negative sign, you should be factoring out a negative term. So for 16 and 48, like the common factor is 16, but I'm going to specifically factor out negative 16. That way, this second set of parentheses matches what we already had in that first group. So 16x, negative 16x divided by 16, negative 16 leaves you with x. And then positive 48 divided by negative 16 leaves you with negative 3. So these should be the same. If they are not the same, something went wrong. Because they should be identical, because that's going to be your second factor. And if they're different, then that would technically be 2 different things. So second set of parentheses, once you factor out a common term, should be the same. And then the part outside goes to one set. So what you pulled out, x squared and negative 16, becomes one set of parentheses. The part that is the same will be your other set. So you just have to check when you have an x squared term, you need to check that you can't factor further. Sometimes you can, sometimes you can't. When it is a difference of squares, you can factor x squared minus 16 further. So x squared minus 16 can break down into x plus and x minus 4. So when you say factor completely, you would want to take that last step. If you can break down a quadratic any further for factoring, you want to. X minus 3 can't do anything with that. But any x squareds you want to check. So let's try number 9. So first group x cubed, 7x squared, we can do x squared. That would leave you with x plus 7. And then 9x plus 63, they're both divisible by 9. Would leave you with x plus 63 divided by 9 is 7. Again, what's in those parentheses should match. Okay. Outside GCFs go to one set, x squared plus 9. Set that's the same becomes your second factor. So can you factor x squared plus 9 further? You cannot. You can only factor a difference of squares. So because you had x squared minus 16 in number 8, you can break that up. X squared plus 9, I get it. They're both squares, x and 3, but you can't multiply to get positive 9 using a positive and a negative. So you can only factor a difference of squares further. A sum of squares just stays. Can't do anything with that. Okay, how about number 10 on the next page? So, yes, there's no numbers, but you can still pull out the common thing, the common term. So between RA and RB, the common term is R, or common factor is R, leaves you with A plus B. Common term of SA plus SB, S. Part that you pulled out becomes a set. Part that should be the same is your other set of parentheses. As long as nothing is squared, can't go any further. You only need to check when you have a quadratic or higher left. Linear expressions are fine. Okay, how about number 11? 2x cubed plus 10x squared plus 3x plus 15. So looking at the first two terms, 2x cubed plus 10x squared. So this time we can actually factor out a number instead of just x squared. So they are both divisible by 2. One has x cubed, one has x squared. We can factor out x squared. And we just divide. So 2 divided by 2 is 1. X cubed divided by x squared leaves you with x. 10 divided by 2 is 5. X squared, take away x squared, leaves you with nothing. Okay, second group. 3x plus 15. They are both divisible by 3. 3x divided by 3 leaves you with 1x. 15 divided by 3 gives you 5. Again, those second set of parentheses should be the same because that's what's going to go in one of your factors. And then whatever you pulled out as the GCF outside. So, quadratic. Can you factor it further? It's not a difference of squares. You can't really do anything with that. It's only a difference of squares that you can factor further. Okay, and then number 12, yep. So we've got 27t to the third plus 45t squared minus 3t minus 5. Okay, first two terms, 27 and 45. You can factor out 9, both divisible by 9. T cubed, t squared, you can pull out 2t's, t squared. Divide. 27 divided by 9, 3. 1t left. 45 divided by 9 is 5. T squared divided by t squared, no t's, leaves you just 1. All right, the second term is negative, so we should be factoring out a negative term here. You need something to go in the parentheses with 9t squared. So if you're looking at 3t and 5, and you're like, well, they don't both have a t, 3 and 5 can't pull. You need to have something. So worst case scenario, factor out a 1. In this case, specifically a negative 1. But you need something to go in that set of parentheses with the 9t squared minus 1. All right. Negative 3t minus 5 divided by negative 1 will now just be positive 3t plus 5. And that checks out because, again, they should match. That's what becomes your second set of parentheses. 9t squared minus 1. It's a quadratic. Can you factor it further? are they a difference, a subtraction of two perfect squares? If they are, you want to break that down. They are. 9 and 1 can be 3t minus 1 and 3t plus 1. And then don't forget to include the 3t plus 5 from up above. So you guys can only factor difference of squares further. Sum of squares you can't do anything with. But you just factor out the GCF from the first two terms, GCF from the second two terms. One set of parentheses should be alike. That becomes one set. Whatever you pulled outside as your GCFs becomes your other set. Check to make sure anything squared can't be factored further.